All right, today I'm going to be learning about linked lists, and I tried to go through some articles and some YouTube videos and just made my own slide, and also attempted a small question on LeetCode, which I submitted and successfully. All right, so we'll first go through the basics, and then we'll attempt this easy question categorized as easy, and then we see how everything fits together. All right, so what's a linked list? So, you know, uh, a linked list, think about it as, a data structure that has connected nodes. Like, you have one node connected to the next, connected to the next, connected to the next, like that. Now, there are other data structures that present um, um, connected nodes. For example, like a binary tree. Uh, if I go to the images, so a binary tree looks like this, or a graph. Uh, okay, graph data structure would look something like this. All these have connected nodes, yeah? But the difference here, as you can see, is that uh, this is different in a way that you have one node connecting to the next. We don't have, for example, node A connected to four nodes at once. No. Like you can see here, this node is connected to four nodes, other nodes at a go. If I go back to this, you see that a binary structure, a binary tree has like each node connected to two other nodes, R and stuff like that. So, but for this one, each node is connecting to the next node like that, one node. Yeah, so that's what it is. So the first node is called the head, and then the last node are points to nothing. It doesn't have like point to the next node. So for the first head, for the first node we call it the head, and then the last one we can identify it by knowing that the next points to nothing. All right. So that's those are the things to note about this. So each node uh, has its data and then the address to the next node. Yeah, like that. So this is how it is, and this is like an example. So would be having like node one, the data is one, and then the next has the address of this next node, which has two, and then with the address of the next node, like that. So how is a linked list implemented? So rather than show it here, I just linked some article that I think explains it well. So we can start with creating a single node. A single node would be implemented like this, with data and then next. So initially, the first node would have data, and then next points to nothing. That would mean that being the first node. Yeah. So if I run this, this is what would be the outcome. So this is one node. So how do we now join nodes to create a linked list? So this node, uh, this is a linked list with one node, having added one node like that. But then we want to be able to have multiple nodes. Yeah, so there is this insert method, which basically ensures that the node you provide is basically added to the previous nodes to to become the next node. Yeah. So with this, once we insert this, insert that, now it all makes up a what? A, a linked list. If we wanted, we could print this one in another way that for it to look like a linked list. But for now, this is sufficient. All right, so that's it about implementing. So let's look at the types of linked lists. So we have singly linked list, we have doubly, and then circular. The way we hear the names is the way they basically are represented. So the singly linked list, this is the initial normal linked list where we have each node connecting to the next, uh, you know, like this. So we have one connection between the current node and the next node, current node and the next node, like that. So that's it. Then we have a doubly linked list. Now, with a doubly linked list, we previously saw that a node stores the data and then the address to the next node. But a doubly linked list stores um, a node stores the address of the next and then the address of the previous one. So which means that, for the single linked list, we can only move in one direction. Yeah, but with this, we can move in either direction. So if I'm on this node, I can I can know the next node by using next. Okay, but I can also know the previous node by using the previous address. Yeah, so this is how it is. So with this being the head, then I move to next. The last one points to null, points to nothing basically. Then the previous one, if I'm coming in the opposite direction, previous points to the previous one, like that, like that. Then this first node doesn't have a previous node here, so like that. Yeah. So that's mainly what we need to know about double linked list. Then our circular linked list. This The only thing here is this is like the singly linked list, but the only thing is that the last node points back to the first one. So the next of the last node has the address of the first one, so that makes it like a circular linked list. All right, so let's look at the list operations. So we can traverse, the list. We can insert, delete, search, and sort. So traversing basically means going through the list node by node. Um, and then we start from the first one and then until the last one, which has next as none. So that's how we traverse, basically traverse in that, one direction. Um, if it is a single linked list, and then our you could also traverse in the opposite direction for the doubly linked list in either direction. Yeah. So, but the main thing is that we are moving from node to node to node to the next like that, or previous like that, depending on which linked list we are dealing with. So it's basically an iteration. Yeah. Um, so let's look at inserting now. Main thing about inserting is we can insert at the beginning, at the end, or in the middle. Yeah, and in the middle we can insert at a given node, after a given node, or before the given node. Yeah. So inserting at the beginning. So what we basically do, remember the first node is the head. So all we have to do is our new node, we just point it to the current head. Now, once we point it to the current head, uh, now the new head becomes our new node. Yeah. So the main thing we really have to do is to just point it to point the next to the head. Yeah, and then that makes it the first node. So the code would look something like this. Yeah. So our inserting at the end, we have to traverse the whole list until the end, and then we now link the last node with our new node. So um, um, so how we traverse, we've already seen how to traverse. So the last node would be the node that has next pointing to none. Uh, So once we reach that node, we know that we are on the last node. And then we point that next, it, we point the next of the last node to the new node. Yeah. So the main thing we need to do is to find the last node and then point it to the new node. So now that means that our new node would become the last node. Yeah. So the code would also look something like close to this. Yeah. So inserting in the middle. Now let's say we have a node like this 10. So when we insert, we can decide to insert after or before. Now, if we are to insert after, we find the node. If we are inserting, let's say after node 10, we find node which will be our target node. Then we disconnect its next. We disconnect it from 15 and point it to 20 to the new node. So we would just change the next uh, pointer to point to our new node, and then we get our new node points to the next one. So we basically just rewiring and fitting it in the middle. So the code would look somewhat like this, but the most important is the idea. So if we are connecting it to, if we are adding it to the previous node, if we say, okay, insert it before 10, not after 10, then we would have to do the same. Our, so we would have to find our current node, which would be 10, and then our, use our previous node to use our previous node to now to rewire. Yeah, to rewire. So it's just a matter of understanding what's going on, and then one can rewire accordingly. Yeah. So and one thing I forgot to mention, if the list is empty, then you can't add in the middle of an empty list because there is nothing to add to. So in that case, we would be, would just return an exception or say the list is empty. Or if we are to find a node 10 and we can't find it, that means we don't know where to put to insert our node. So it's also, we return an exception indicating that, yeah, we can't find the node. So how do we remove? So when we disconnect a node on both ends, then it's deleted. So you imagine a node, a linked list that looks like this. So if we want to delete 15, we basically disconnect. We will make sure that it points to nothing, and then the node that points to it, we rewire it to point to the node after that. So if a node is pointing to nothing and no other node is pointing to it, so it's left hanging and it's naturally taken out of the linked list. So it's dropped basically. Yeah. So that's how we delete a node. So when it comes to searching, we just traverse or we just iterate, and once we find the node we are looking for, we just return it. Yeah, so that would be basically it. Um, Now, we could also um, talk about sorting. How do we sort? We can use bubble sort. There may be other ways of, we could use other sorting algorithms, but uh, initially we could sort this using bubble sort, uh, and then have it sorted. Yeah. So I want to go into the details of how that would work because basically bubble sort um, is what we can use. Yeah. So one would just get to know how bubble sort works and then be able to use it to sort. Yeah. All right. So going back to our challenge here, we are asked to our LeetCode challenge, we are asked to convert a binary number in the linked list to an integer. So our given a head, which is a reference node to a single linked list. Okay, basically I read through the question and then we can attempt it. But since this is a video, you can pause and read through, but I'll just go ahead. So we basically imagine a linked list that looks like this. So this would be the head. This is you know, the last node. So uh, we are only going to be pointing uh, our nodes are going to only have values of either 0 and 1, 0 or 1, 0 or 1. So for example, with this, this means that the data that is in is 101 and the output of that is the decimal value of 101, which is a binary number, is 5. So 101 basically in base 2 is this. So our goal is to take whatever linked list that we are given and then uh, determine the decimal value. All right. Okay. So if I run this code, I already submitted this, but we see that our input is this and then our output is this. So basically, the approach we will take is that at the end of the day, um, at the end of the day, at the end of the day, we want to have a value that looks like this, such that we can easily convert it to a decimal. So let's think about our end goal. Our end goal is if we have our value like this, we can actually convert it to a, a decimal value like this. So if I print this, um, we'll see what we get. Okay, let me just put another, sorry. If I print that, so you see this would be 21. Yeah. If I print this, that would be 5. So my approach here is that I just need to have whatever is in my linked list, and convert it to a string and have a string like this, which I then can easily turn to a decimal value. Yeah. So so my first thing is, since we will convert a binary string to a decimal, we want to have to concatenate each of these values in the nodes, to concatenate them and end up making a string. Yeah. So how will we do that? We'll just traverse the list and append the values to the initial value. So if we have start out with an empty string, then as we traverse the list node by node, we could keep appending or concatenating, yeah, the values, each value at whatever node we are at, we concatenate it to the original. Yeah. So I will again uncomment out this code. Boom, 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 boom. Perfect. So we start out with a function like this. Um, so this takes a head and then the binary string. So the binary, what I'm calling a binary string would be basically a string that we start out with that uh, would be initially an empty string. Yeah. So um, if as we are going through our nodes, once our next node, once the node is none, then it means that we are at the end. It means that we have reached the end. So because if even for the last node, the next will be none, but the entire node will have a value. Yes, but if we reach a point where um, the node is none, it means we basically can't continue. We have exhausted, and at that point, we should take whatever string we have and convert it. Yeah, so that's what it is. So and this is a repetitive process. So if I was going to do this manually, I would I would if we start with this first node that is the head, uh, we concatenate it. Then if we move to the next, our new node will be head.next, and we pass now our already concatenated value, and then we pass that. So this will be called recursively, and um, and that will do the magic. So if we try to return the value, we initially pass the initial uh, linked list that we have, and then we specify the starting string, which would be an empty string. Yeah. So that's basically it. So this will basically give us the correct output. Yeah, perfect, like that. There could be several approaches. One can, check the solutions and see the available approaches. Other people would approach it differently. Uh, there are also discussions that show, if I say Python 3, um, there will be several approaches by people. Let's see that. So yeah, but this is my approach and how I thought about it. Yeah. So yeah, thank you.